Today's lesson on the order of operations from Chapter 1, Section 2 of your algebra text will focus on evaluating numerical expressions only. As you may remember, numerical expressions are different from algebraic expressions. They will only have numbers in them. You've probably seen the word PEMDAS before when you've talked about the order of operations, because this is a great way to remember the order in which you should evaluate a numerical expression. PEMDAS is just an acronym that helps you remember the order to perform these operations in by performing parentheses first, followed by exponents, multiplication and division, addition and subtraction. Probably the biggest misconception with the order of operations with PEMDAS is that because they're written in order with P, E, M, D, A, and S, a lot of students forget that multiplication and division actually go together at the same time from left to right. The same is true about addition and subtraction, that all addition and subtraction should be evaluated at the same time from left to right. Of course, when I'm talking about evaluating, all I really mean is when you evaluate an expression, just perform the particular operation, such as if I want to evaluate 6 plus 4, I know that I want to evaluate addition here, and the expression becomes 10. But how about when numerical expression becomes a lot more complicated? 6 plus 4 minus 2 times 3. Well, here's where our order of operations, or PEMDAS, will help us remember what order we want to evaluate this particular numerical expression in. So I'm going to look up here first and see that with parentheses, well, there are no parentheses in this expression, so I'm going to move on down to exponents. Again, exponents don't show up in here, so don't forget we want to evaluate multiplication and division together from left to right. I only see multiplication in here with 2 times 3, so I'm going to evaluate that part of the expression right now, and 2 times 3 is 6. But I want to keep the rest of the expression before evaluating the rest of it. Now you can see here I have 6 plus 4 minus 6, so I want to evaluate the addition and subtraction here from left to right. So starting with 6 plus 4 is going to become 10 after I evaluate it. And of course I still have the rest of the expression, and I'm subtracting 6 from 10. After evaluating the numerical expression, I am left with a total of 4. Of course, that is the simplest numerical expression here we'll evaluate today. Let's continue to look at a couple more. Here's one that, again, if you remember your order of operations, if you remember PEMDAS, this will help ensure that you can evaluate this expression in the correct order and get the correct solution. So here I'm going to look and notice that, again, I see no parentheses here in this entire expression, but I do have an exponent, so I'm going to evaluate 2 to the 3rd power first, which is, of course, 8. 2 to the 3rd power indicating 2 times itself 3 times. 2 times 2 times 2 is 8. And I still have the rest of the expression to evaluate here, leaving me with 48 divided by 8 times 3 plus 5. So parentheses and exponents are done. Moving along to, don't forget multiplication and division from left to right. Here's where it's really easy to make a mistake. If you believe that multiplication comes before division, you might want to multiply 8 times 3 first. However, we have to remember that multiplication and division are showing up in here, and we want to evaluate all of that from left to right. So looking at 48 divided by 8 first, that should give us a total of 6 when it's evaluated. And if you leave the rest of the expression, now we can multiply 6 times 3, of course, giving us 18. Still have to add 5 to finish evaluating the expression, giving us a total of 23. Of course, certain types of grouping symbols will come in here. When we notice parentheses, we call them grouping symbols because these symbols group together certain operations that we want to happen before any of the other operations. So here parentheses are going to indicate that I want to subtract this 3 from the 8 and I want to add 3 to 2 before I do any of the other operations. So I'm going to go ahead and do the things that are in parentheses first. Don't forget that when you talk about the order of operations, parentheses means do the things that are in the parentheses first. So I'm going to go ahead and subtract 8 minus 3 in this set of parentheses, leaving us with a total of 5. And 3 plus 2, again, gives us a total of 5. Don't forget here, when you see a number right outside of the parentheses, all that's indicating is multiplication. So we really have a total of 5 times 3 times 5. So here I will go from left to right. And all I've got left, the only operation I have left here is multiplication. So remember that multiplication is commutative, meaning we can group this in any way that we want. Probably the easiest way to do this in your head real quick is to notice that if you know that 5 times 5 is 25, then we've got 3 sets of 25, or we have 3 quarters. So that helps lead us to our final answer of 75 very quickly there. Sometimes when you use grouping symbols, you might see parentheses and brackets together. Just think of brackets as another type of parentheses. They're just a kind of the outside portion. When you want to have multiple sets of parentheses and you want to have parentheses within parentheses, you can kind of help determine which parentheses belongs with which, and you can easily see that this entire set 6 minus 2 is within this set, this bracket here. So when you are evaluating, you have multiple sets of parentheses. Always go ahead and evaluate the innermost set of parentheses first. So I'm going to go all the way inside here and see I've got 6. Sorry, I have 6 minus 2. So after evaluating the innermost part of parentheses, 6 minus 2 does become 4. But I've still got everything else in this expression left to evaluate. So now that I've evaluated the innermost part of the parentheses, I can now evaluate everything else within inside this bracket, which is 12 divided by 4, which is in fact 3. And again, don't forget that the number right outside the parentheses, is 4 right here, that is right outside the parentheses, is only indicating multiplication. So if I have multiplication, 4 times 3 to the second power, I want to evaluate exponents first. Now I've done everything inside of parentheses. Now I will move along to the exponents. It could be really easy to make the mistake of multiplying 4 times 3 and then taking it to the power, but don't forget that our order of operations asks us to do otherwise. So 3 to the second power leaves us with 9. And then we'd go ahead and multiply by 4, leaving us with a total of 36. Finally, the last example here today is oftentimes in numerical expressions a fraction bar will show up. Fraction bar, just remember all fraction bar means is division. It's just a type of division. Well, you might be asking, division appears right here in the order of operations. But when you see a fraction bar, always think about it as a grouping symbol. just like you would a set of parentheses. So when you're evaluating a numerical expression with a fraction bar in it, always evaluate the numerator separate from the denominator, and it should leave you with a fraction at the end, which you can evaluate with division. So let's go ahead and evaluate the numerator part here first. If I've got 2 to the 5th power minus 6 times 2, I want to evaluate exponents first. There are no parentheses, so I'm going to evaluate the exponents first, and then I am going to look at 2 to the 5th power. Again, remember that 2 to the 5th power means 2 times itself 5 times. So 2 times 2 times 2 times 2 times 2 leaves us with 32. So I'm going to leave my fraction bar here, and I'm going to work down. So that 2 to the 5th does become 32 minus 6 times 2. And I'm just going to continue working there with that top half and try to evaluate the numerator of this expression first. So you can see that I want to next go ahead and follow the order of operations, which asks us to do multiplication and division next. So my multiplication here of 6 times 2 gives us 12. And all that's left to evaluate in the numerator is 32 divided by 12, which is in fact 20. So the top half, when evaluated, top half of this fraction, this numerical expression, when evaluated, turns into 20. And now let's go ahead and look at the bottom half here. And in the bottom half, of course, again, I want to remember to evaluate exponents first. So I've got 3 to the 3rd minus 5 times 3 minus 2. So when I evaluate exponents first, I am left with 3 to the 3rd. Again, remembering that 3 to the 3rd is 3 times 3 times 3, which leaves us with 27. The rest of the expression is minus 5 times 3 minus 2. So looking over here at my order of operations, the first thing I want to do, not subtraction, but multiplication. So I want to evaluate that 5 times 3, which is in fact 15. So I'm left with 27 minus 15 minus 2. Now the only operation left is subtraction, so I can go ahead and evaluate everything from left to right here. 27 minus 15 leaves us with 12, and 12 minus 2 does in fact leave us with a total of, does in fact leave us with a total of 10. So our final expression is 20 divided by 10 when I evaluate the numerator and the denominator separate. But don't forget, we've got this fraction bar. As we know, fraction bar indicates division. So I'm going to divide 20 by 10, leaving us with a total of 2 when evaluating this numerical expression. Your next video will be focusing on evaluating algebraic expressions.